What is up, everybody? Welcome once again to Building Stuff with Nova. I see you, Twitch, YouTube. Welcome back once again. Super happy to have y'all with us at our virtual makerspace, our ideation laboratory, our mastermind, the place where I and you and me and us and all everybody here, we building together. I'm Dr. Nehemiah Mabry. I'm your host. You can call me Dr. Nee, and I want to know who's with us. I am keeping an eye right now on the chat, not only on Twitch, but also on our Nova YouTube channel. That's right, we are on both, and we would like to welcome everybody for joining us here again. By now, you all know the drill. We come on live every single day. We're every day on Twitch, but we're also occasionally on YouTube and other Nova platforms, TikTok, Facebook, and the like. But we love you all, and we're so happy to have you all with us. Nova, how are you doing today? Thank you for welcoming everybody into the stream. Let us know how you're doing today. And if you are brand new here, now is a great time. Now is a great time, I must say, for you to hit the subscribe button on YouTube and to hit the follow button over on Twitch. I'm going to tell you why, because we got some pretty cool stuff that's happening in the very near future. We are at the end of September, which means that a month from now will be the end of October. And that happens to be, you guessed it, for those who've been here before, the finale, the pinnacle of our season of Building Stuff with Nova, where we are going to host a 4-part engineering themed escape room. That's right. Okay, we see you, M. Good to see you, Nick. But yes, a 4-part engineering escape room where we are inviting people, you, our community, to apply to be a part of that event. Now, I want you to know, this is the last day, October 27th. I mean, not October 27th, September 27th. This is the last day we are accepting applicants to be a part of the in real life portion, which will be a 4-part engineering escape room, as I said, hosted in Boston, Massachusetts at WGBH or GBH Studios there in Boston. If selected, you got to go ahead and drop the link, Nova. Let people see the link. We are dropping the link right now on our Twitch channel. If you're on YouTube, you can come over to the Twitch channel and check that out. But we're dropping a link where you can apply to come and be a part of that grand experience in real life. Now, the event is going to be opened up for anybody. Anybody who's watching the stream can be a part, including you, chat. You're going to help save the world as our game is designed from the hazards of Y3K. Yes, we're going to solve engineering puzzles through the 4-night experience and help us to restore and retrain the algorithm that we have at the point of Y3K become too reliant upon. And that is going to be what the games are all about. But again, we have at least one spot for you if you apply and are selected. So go check out that link. It is now in our chat on Twitch. You got to come over and check it out. So that's right. Thank you for keeping that in mind. And again, today's the last day. So get it in if you want to be considered. Not only that, let me tell y'all what else we got going on. Before I bring our guests and talk about our agenda, we also have a survey. Now, we've been doing this for months now, and this has been a lot of fun. If you ask me, I've been having the time of my life going to aviation museums and fusion laboratories and building trebuchets and making sure that I'm playing games with you all's help. This has been very fun, but we want to have a survey where you can tell us what you think, because this is all a part of a research project. Yes, we have been exploring the process of engineering, engagement, education in informal spaces. That's why Twitch has been really a fun house for us. And even doing this on YouTube and other platforms, it's an opportunity for you all to chime in and let us know, hey, what do you think about it? What have you learned? Has it been engaging? What are some of the things so that our partners, NSF, can know exactly what this project yielded and how successful it was? So check out the link that will be dropped into the chat periodically. I won't always shout it out, but Nova will drop it periodically throughout our stream today so that you all can give us your insight. How does that sound, everybody? Is that cool? Is that cool? Does that sound great? I see you over in the chat. Shout out to everybody again on both Twitch on and on YouTube. If that sounds good, let me know. Lit, Ducktail said. I love it. I love it. All right. So here's what our agenda is for today. We have another guest, Dr. Francis de las Reyes, and he is going to come on here in just a second, and we're going to talk about where our poop goes after we flush the toilet. I love the fact that we have an engineering professor today that is really passionate and an advocate globally about sanitation and water reclamation and many other things that he's going to share with you all today. So Razzle Dazzle herself, I want you all to be really, really enthusiastic right now as we get ready to go and show our interview, our virtual field trip, but also host here live our guest, none other than Professor, Environmental Engineer, Global Advocate of Sanitation, none other than Dr. Francis de los Reyes. How are you doing, sir? Good to see you. Can you hear me?
Hey.
Hey, there he
Yes,
is. He's there.
hey. Hey, good to see you, Dr. Nee.
Yes, absolutely. Super happy to have you all. You all get some love coming in the chat. I'm looking for your emotes, looking for your vibes. I see the emotes, the claps, ducktails. Thank you so much. You are joining us from a nice, beautiful campus I see behind you. Are you is that your workplace that we see?
Yes, this is Centennial Campus, and you can see the building on the left is Fitzwillard Hall. That's where our department is, Civil Construction and Environmental Engineering at NC State University.
Yes, North Carolina State University. Go Pack, right? Chat knows that's where I got my PhD from. You work on Centennial Campus, as you just said, and that's a fairly new building there, Fitzwillard Hall, housing the Civil Construction and Environmental Engineering Department. Is that right?
That's right. We moved in 2020, 2021, so just a few years ago. So it's brand new. Really love it.
Got it. Shout out to everybody in chat. So here's what we're going to do. I'm not going to belabor this, but I want you to know that Dr. De los Reyes and I, we had the opportunity to do a little vlogging last week, right, Dr. Francis?
Yep. That was fun.
We did a little vlogging, a little day in the life, or I don't know if it was a day in the life of a person, but more so a day in the life of toilet water, if you will, so to speak. And this is how it's going to go, chat. This is how it's going to go. We're going to watch and just kind of show some footage that we were able to capture. And periodically through our video, we are going to stop and pause and ask questions. So if you see things, if you hear things that intrigue you, you can go ahead and drop your question in the chat. We'll let it play for a few minutes here and there. And throughout this entire experience, we're going to get additional context and insight from our guest, Dr. De los Reyes. Does that sound good, Dr. Francis?
That sounds good, Dr. Nee.
Sounds good. All right. So here's what we're going to do right now. I got to warn you all. We got a nice little code open, a nice little code open here with our visit to a local water facility. We'll tell you exactly how we refer to it in a second. So check this out, y'all. That's right. Razadell, buckle up. You all can see where we're starting. Where we're starting this. Here we go. What I did in there should be illegal. Wash my hands. All right, make sure. I think it's about time to get there. Hey, Doc. Hey. It's Dr. Francis de los Reyes.
Hey, Dr. Nee.
Hey, what are you doing here?
You told me to come meet you up here at the Water Resource Recovery Facility.
Oh, yeah, that's right. I did tell him to meet me here. Well, yeah, what's up?
Well, do you know what happened just there?
Oh, you mean where I just lost about 10 pounds? Yeah.
No, but do you know what happened when you flushed that toilet?
When I flushed it? No, but I got a feeling you're going to let us know. Let's see. When I flushed this toilet, the water went down the hole, right?
Well, yeah, that's right. It all disappeared, right?
Yeah, down to the sewer.
Exactly. But do you know what happens to all that dirty water that went to the sewer?
No, but that's why we're here, I guess.
That's right.
All right. So what happens at this water resource
recovery facility? So sometimes people call it the wastewater treatment plant.
Yes.
Yeah. So that's one of my most favorite things in the world, is actually to talk about what happens to all that dirty water.
What are your most favorite things in the world? Okay.
Exactly.
All right, I'm ready to go. Take me on the tour. Show me a good time.
Okay.
Where are we headed now?
So this is the control room.
Okay.
Of this particular facility.
Okay.
Go ahead, yeah.
This is where everything is monitored.
Controlled.
And controlled, okay.
What you're seeing out there is actually the whole wastewater treatment facility. We'll follow the flow of the wastewater. It goes through all of these physical, chemical, and biological steps until it's ready and clean and okay to be discharged into a receiving body of water like a stream.
So is this some sort of, like, I don't know, for lack of a better word, obstacle course that is going through sequentially, like
Yes.
in different orders, and then eventually coming out clean on the other side?
That's right. So,
Okay.
so there's a water bath, and then there's also some other products of the process, like we call them the biosolids, that also follow their own treatment process. But what you can see here are all of the controls,
Okay.
monitors, so that the operators actually can control pretty much what's going on in the plant from here. They can turn valves on and off, pumps on and off. There's a lot going on in terms of mechanical equipment, because what you're trying to do is you're trying to make sure that the process is optimized.
Got it. So people, the workers here, use this as a virtual representation of what's happening out there. Right. The chemical, the mechanical, all of the processes.
Biological, yes.
And we're able to tweak some of, like the pressure. What are some of the other things that are being adjusted?
Right. So there's a lot of sensors out there. So for example, the dissolved oxygen, which is a very important parameter. It's the amount of oxygen that you actually are pumping into the water. That's important because the microorganisms are using that oxygen to convert the waste, right? So that's how they grow.
Okay.
And so there are sensors there that tell you when the DO, dissolved oxygen, is going up or down. And then depending on those numbers, they can turn valves on and off, or slow it down or speed it up.
Okay.
So that's how you basically control the growth of the microorganisms.
How did the water, after I flush it, get here? Like, is there a whole process of how it even gets to this place where it's purified?
So at your house, right, wherever you live, you flush the toilet. There are pipes under your house. And the pipes from the different houses in your neighborhood all collect and join together into bigger and bigger sewer lines. And then those sewer lines end up actually here at the wastewater treatment plant.
So basically, the sewer routes everything here,
That's
or
right.
in whatever part of the city, to its most convenient or assigned water.
Well, so sometimes gravity alone will not be enough, right?
Yeah.
So as much as possible, you want gravity to work for you.
Yes.
And that's why typically the wastewater treatment plant is near the discharge point, a river or a creek. It's a little bit lower than the rest of your city, ideally. But sometimes it's not enough, so then you have what's called pump stations.
Okay.
And so you collect all of that wastewater, and then these pump stations, the giant pumps that provide energy to keep the water going.
Keep the water going.
That's right.
And that includes the water that was just flushed down the toilet.
That's right. Yeah.
Okay, all right.
So your water joins a bunch of other water.
Joins a bunch of water, okay.
Right. Yeah.
Yeah.
There is. I want to stop here real quick, and I saw that everybody in the chat, everybody's noticing things. They said, "Man, they got a little nervous watching this during lunchtime." That's hilarious, Kaja. Yes. So I just want to point out something real quick. We talked about, we started with our little sketch. I know you all saw that little nice little cold open we had there. But you were sharing that, sometimes gravity is used, but other times pump stations are used. I think that's sort of two things that come to mind. One, I think that it's probably one of the things that differentiate sort of developed areas versus probably less resource countries. Is that true?
That's right. Yeah, if you think about all these sewer lines, Dr. Nee, there are actually in any given town or city, maybe thousands and thousands of miles of pipes that you don't see. They're buried under the ground. And they basically are, collecting all of that wastewater. And that's a lot of money if you think about it, right? Think about how, you're laying out pipes underground. And in a lot of countries, in, low and medium income countries, they don't have those kinds of resources. Maybe they don't have the space. But really, it's really, really expensive. It costs, if you think about per mile of pipe, it can be as high as, $1 million or more.
Wow.
And think about all of the infrastructure that's buried that we don't all see. And then the other part of that is that these are pipes that need to be replaced, every, 30, 40, 50 years. And some of the pipes that we've laid down in cities have been there for a long, long time, and we know we've got to replace them. So we do have an infrastructure problem with respect to collecting all of that wastewater.
Right. So all this that we kind of saw, like, it's not just the city, but it also is kind of the resources that are involved in the actual plant itself. And that's why I'm rewinding a little bit, because we saw like the nice controls. We saw a lot of different aspects of this. Even that would be a little different in, I guess, less resource parts of the world as well, right?
Yeah, I mean, some of these processes are fairly standard
Uh-huh.
in terms of, engineering. It's kind of like, think about buildings, right? So you might have differences in buildings in one country to another, but they're all buildings and they fulfill the same function.
Right.
Um,
Got you.
but obviously, we have a lot more sensors, we have a lot more controls.
Right.
In countries like the US, where you want to minimize the labor component, you want to automate things. But in some countries, a lot of things are more manual.
Right. Okay, cool. You all get your questions coming. I'm going to make sure we continue to watch this. But the last question I want to ask, and I'll be keeping an eye on the chat. I see you, Razadado. Shout out to wastewater treatment plants and those who run them. As a kid, we had to use a bucket during a hard freeze that locked up the plumbing. So ever since then, Razadazzle says in the chat, they never forgot the value. They know the value of places like this ever since that experience. So that is really good. And then my question really quick before we keep it going is, I think I had this thought when I was there. When I actually flushed the toilet there, it has to go out of the plant and then go back into the water sewage and then come right back to the plant. Like there isn't, like what we were talking about, there isn't no like shortcut to the treatment plant since I was already there.
There isn't, yeah. So this is one of those things, right? Think about your Wi-Fi also. It goes around the world before it gets to the next building. Yeah.
Got it. All right, let's keep watching, y'all. We're going into a laboratory, as people kind of already saw there. Here we go. Water laboratory where you take samples of water.
Water that's going in, different points along the plant, and most especially when it's going out.
Yeah.
And they're measuring all of these things: the organic matter, the nitrogen, the phosphorus, the suspended solids.
Right.
To make sure that the water is being treated the way it should be, and especially before discharge.
Got it. One more question too. I got to be honest.
Sure.
This doesn't smell like a wastewater lab. It
wait
smells very clean.
Wait till we get out.
Wait till we get outside. Okay.
No.
This is more on the clean side of things.
No, actually, I mean, you'll be surprised that wastewater it's not really bad.
All right. Well,
that's right. And also, I mean, over here, you bring in the samples, so you can see they've got things like an autoclave for sterilizing things. They have all kinds of pH meters to measure the pH of the water. All kinds of equipment. Want to make sure that they have a lab that's functioning, that's actually up to snuff. So it's certified, because you got to trust the data, right?
Yeah.
Right. So we have to make sure that
the lab is functioning at a level where you can get reliable data.
The lab people are trained.
Yep.
The numbers are things that we can have confidence in.
Right.
So it's something that's required by law. And, most good towns, they try their best. And this facility, they have lots of capabilities in terms of testing the water, making sure everything is up to snuff.
All right, so
I gotta ask you something.
I see.
What was this for the people who watching? Because we're about to go outside here, but they saw the refrigerator there, and that's not your typical refrigerator contents there. Can you talk a little bit about this really quick? What they see here on this particular part of the club?
Yeah, so they're labeled FEFF, that's effluent, or what's coming out of the plant, and then maybe you saw INF, influent, what's going into the plant. So we try to measure the water quality coming in, going out, making sure that we're meeting the standards. And we put it in the fridge because we want to make sure that the samples are properly stored and there's not any changes that we don't want to happen while we're in the process of measuring things, right? So we want to make sure that, again, the data is reliable and we know what's going on in our plant. Yeah.
What's that in the bottom there?
So
because these are different. These are samples throughout the process. Like you can kind of see how it is at each stage, right?
Right. Yeah. So, there's a lot of solids in the influent. You can imagine, whatever people flush. A lot of the big stuff, and you'll see this later, a lot of the big stuff is screened out. So we don't see those, the logs, the big sticks and so on.
Yeah.
But the things that can get through are things like this, like solids. Maybe there's some toilet paper there, but most of that should also be disintegrated into the water. Yeah.
Got you. And you, as you already mentioned too in the clip, there are government regulated certifications or let's say standards that have to be passed at each level or each stage of the process, right?
That's right. So depending on the wastewater treatment plant and where it is located, there are different levels of stringency, right, or strictness in terms of the permits or the limits. So if you're in a more sensitive area, so for example, up and down the East Coast, where we have sensitive waters, we have a lot of fish, we have a lot of you know aquatic life, we actually have stricter standards than in some other areas where it's less sensitive. So that's the permits are basically from plant to plant. In a place like this, which is a relatively big wastewater treatment plant, this facility has a more strict levels or permits that they have to meet.
Got it. One quick question from chat before we keep going is, do y'all test wastewater for COVID at this facility? It remains one of the most valuable. Does that happen?
That's a good question. Yeah. So actually, what happened over the pandemic was a bunch of scientists and engineers like me realized that we can actually test for SARS-CoV-2, the virus, in wastewater. And that became a really nice example of scientists coming together during the pandemic. We figured out collectively as a community how to measure SARS-CoV-2, the virus itself, and we use molecular techniques like RNA to detect SARS-CoV-2 in wastewater. And that became quite successful, so that now the CDC actually has a national program. And our state in North Carolina, we are actually part of that, and we have our own COVID wastewater surveillance system. And that gets reported. It's a public database. People can take a look at that and take a look at, NC, wastewater surveillance. They can find a dashboard. This particular facility, yes, it's part of it.
Yeah.
And there are several, facilities around the state that are part of that. Now, in addition, Dr. Nee, we actually are also testing for things like RSV,
right,
which is this new upcoming virus, flu, so influenza virus, and also Mpox. And we're trying to figure out, how can we use wastewater surveillance for those kinds of things.
That's powerful, y'all. Y'all gotta show some love for that. Wastewater surveillance is a whole field and craft that I didn't even know existed, but that makes sense. You got to make sure you're testing for this thing. Great question, Razadasso. Let's continue to watch what we got going on here as we go outside of the building.
All right, so I see dark water over here.
We'll get to that.
We'll get to that, okay.
So think of the water as coming in this way, right? There's actually, in this particular plant, there's actually a pump station down that ridge there that actually pumps all of the wastewater in.
Yeah.
And also there's some initial screening. So those are huge screens with maybe 1-inch openings.
Okay.
So you don't want logs, you don't want sewer rats,
right. Yeah, right.
dead animals, right?
Body parts.
Human body parts.
Yeah.
So you take those out, and imagine it's coming in here. And so this is the first step, right? So what?
I'm catching a whiff already.
Yeah. So what this is called it's a partial flume.
Okay.
A flume is a flow measurement device, and so when you open this,
ooh, that's raw sewage right there.
That's right.
That's already been screened, but it's still sewage.
That's right. So you can see it's gray. That's your raw sewage coming in.
Oh my goodness.
So this particular flume, this device has actually a sonar.
Okay.
Which measures the level of the liquid, and that level of the liquid translates to a flow. So you can take a look at that right now, and right now there's 8.62 million gallons per day flowing through the plant.
Wow.
You can see that, right?
8.62
million gallons per day.
Million gallons per day.
Right.
Oh my goodness. All right. So let's measure that. All
do you
right.
know how much each person contributes every day?
A day? How much a single person?
Yeah.
How much?
It's about 100 gallons per day.
I didn't know that.
Yep. So about maybe 80 to 100 gallons per day. For you, you're conscious about your water. Probably you're closer to 70, 80 gallons per day.
I am conscious about water, but I didn't even know I was that bad, to be honest with you.
Couple of things here.
Okay.
You can see this is covered, right? If it were open, the smell would be all over.
Pungent, yes.
So this particular facility, they covered it up, and they actually pump out that headspace, the air. through this tank, and it's actually full of sponge-like material and microorganisms that convert all of those odorous compounds to non-odorous compounds.
So this is almost like a whole nother
It's another biological system.
biological filter, so to speak.
That's right. So what
Okay.
it does is it converts sulfides, because the smell that you smell is probably reduced sulfides. Hydrogen sulfide, methyl sulfides, dimethyl disulfide. And so in this particular reactor, you actually aerate them, and the microorganisms convert all that sulfide in a gas to sulfate. And that takes care of that smell.
So once it goes through here, it doesn't have the same stench.
That's right. That's right. So
Got it.
that's kind of like an odor thing. So all of the flow actually is going this way.
Oh, okay.
And this
Redirect
is a nicer, what we call band screen.
it. Okay.
And this band screen actually is not like a screen like that. It's actually got, you know, like a.
It's like a grid.
It's like a grid. That's right.
All right. So these are filters.
That's what the screen looks like, right?
It's a lot of them. They're
Yeah.
small.
They're small,
Beehives.
Yeah.
and so it's pretty fine, right?
Yep.
And so when it's in operation, when it needs to come into play, it actually travels up and down, and then it's washed by jets. Yeah, so that it doesn't get clogged.
So it's self like maintenance kind
It's
of.
self-clean, because this is the nasty part of the plant.
It is.
You don't want people, you know, manually doing anything.
Right.
Yeah.
You're exposing them to a lot of harmful bacteria.
Right. If you take a look at this,
And this is
removing the grit and grease. So when we say grit this time, we're not talking about your favorite breakfast.
yes, not that.
We're talking about sand particles, small pieces of bone, gravel,
Oh.
you know, very small pieces. We want to remove those because those are going to damage our pipes and our pumps. So notice that there's actually motion, there's air only on one side, right? And so basically the air is going up on one side and it's pushing that flow going this way, but the flow is also going that way.
Is it? Okay.
So there is a spiral flow happening here, right? The water is actually going that way, and the sand and the grit is being washed as it's doing that. So the aeration, the very slight aeration, bubbling that we're introducing, does two things. One, it creates that scouring motion, and it also prevents it from becoming, you know, anaerobic or smelly.
Oh, okay.
Okay, so now the grit is going to settle to the bottom,
Yep.
and that grit is going to be pumped out by that. You can see that traveling bridge right there. It's moving very slightly.
Oh, I see. The
It's
bridge
moving
is
forward.
coming this way. And what is that bridge doing?
Yeah, it's moving forward. So that brown pipe right there,
That one's moving forward. That one's moving back.
yes.
Okay.
So that brown pipe is sucking the grit at the bottom and pushing it out the other side. So this is sucking out from the bottom
And pushing it
and
out.
pushing it out on the other side.
On the outside edge?
Yes. And there's
Oh,
another, yeah.
okay.
And there's another pipe that goes there. We'll follow where that goes.
Got you.
Okay, so that's the grit.
Yep.
The other thing that happens here is that if there's any grease or fats, it's gonna flow to the top, and it's actually gonna accumulate on the other side. So you can see some of that scum layer already happening, right?
Yeah.
And actually you can see it on the other side. As that whole bridge is traveling, it's scraping the surface, the scum surface, and it's actually pushing it to that hopper on the other side.
It's almost done right there.
I don't know if you can see. There you go. It's a little bit of scum. Watch out, this is moving. A little bit of scum. And
In
then
the
this-
words of my 5-year-old daughter, ew.
Ew, indeed. Hey, Doc, I got to ask you, here's a question from Razzle Dazzle over on Twitch. And this has to do with like flushable wipes, because there, you know, a number of things that get flushed down the drain that, let's be honest, like, should we be doing it? Probably not, right?
No.
So talk
No,
about that,
no.
because is this where you all have to really combat some of that stuff? Talk about a little bit about the things that, you know, we really shouldn't be flushing, like the wipes, and then also no, go ahead. I won't speak.
Yeah. Flushable wipes, they're you know, you call them flushable, but they're really not. They don't really disintegrate in the sewer line like toilet paper does. And what happens is they get trapped in either they can get accumulated in the sewer lines, because there's something called grease deposits or fat salts and grease that accumulate in sewer lines.
Mm-hmm.
And they can get trapped there and they can clog sewer lines. And that's bad because now if there's the sewage has nowhere to go, it's going to go up, right? It's going to go out into manhole. So you try to avoid that. But if they get through, they will get trapped in the screens. But in general, we don't want we don't want flushable wipes to be in the system.
And is that the same thing for like grease? Because you're talking about like over here, and I'm just replaying this, you all on mute, by the way. And keep your questions coming. But like the grease, is this some of the like grease that we may pour down our sinks and stuff that like we're not supposed? Not we, but
that's right,
people.
right. Right. Yeah. Now in food service establishments like restaurants and so on, or cafeterias, they actually have what's called grease interceptors. So again, these are like tanks that are buried under the ground, and their job is to actually prevent all of that fats, oils, and grease from going to the sewer line. So most people don't know about that, but if you're in a McDonald's or some other restaurant, go around the parking lot, and if you see 3 manholes in a line, that's underneath of that is where the grease interceptor is. And that gets emptied out every month, every 2 months, so that the fats, oil, and grease that accumulate there don't go out into the system. But if they go through the system, that's the fats, oils, and grease that we try to remove right here in this process.
Got it. And that's the reason why, like, again, in food service, you want to catch it sooner because you know that's going to be disposed. But the average household shouldn't be disposing grease like that.
They shouldn't be. I mean, if they could like used oil, if you can put it in a jar, and then every once in a while go to your local solid waste convenience facility that accepts that, that's the best way to go. That's actually the way to go. Or if you just have a little bit of oil, I would say use a paper towel, clean up your pan, and then put that in the trash. That's better management than throwing it out into your sink, down your sink, and into the sewer line.
I'm glad you shared that. And again, no matter what it says, even though it may say flushable, just to go back to that first question, even though it may say flushable, it's still not ideal. And so don't flush.
Yeah, but Dr. Nee, the wastewater treatment plant personnel, they find jewelry, right, trapped in the screens. They find money.
Man.
They find all kinds of weird stuff. People lose stuff.
Sewage
in
mining.
the toilet. So yeah.
Sewage mining.
And okay, something interesting too that we didn't talk about. There's something called sewage mining.
That's what I was just so that was my guess. So there actually is a real thing called sewage mining.
Yeah, so you can actually get a certain amount of gold and silver and some other high value metals from sewer lines.
Wow. And
it's just a question of collecting it and separating it out. But some people have done the calculations, and it's quite significant.
Man. All right. Hey, there's another career path for somebody. We got sewage mining. We also had the sewage surveillance. Hey, so we got some new careers that are popping up here on the water surveillance, rather, but popping up here on the thing. Let's continue to see what we got coming up next here.
In the words of my 5-year-old daughter, ew.
So what's happening here, there's a lot of microbiology happening, okay? This particular plant is unique in that they do something with the aeration. In each tank, they turn the air on and off according to a cycle that's best for the microorganisms.
Okay.
So actually, the water from there. So what's happening here, there's a lot of microbiology happening, okay? This particular plant is unique in that they do something with the aeration. In each tank, they turn the air on and off according to a cycle that's best for the microorganisms.
Okay.
So actually, the water from there actually goes to the head of the plant there. And at the very first reactors, they're not aerated. We call them anaerobic reactors.
Anaerobic.
No oxygen.
Okay.
And the reason for that is we want to promote the growth of certain bacteria. And with the anaerobic followed by the aerobic, you promote the growth of what's called biological phosphate accumulating organisms.
Like these organisms naturally accumulate phosphorus.
Exactly. Perfect.
Got it. Okay.
But you got to have the anaerobic followed by the aerobic for that to happen.
Because you need to get the ones that grow, the bacteria that grows
Under
in the
those
absence
exactly.
of oxygen first.
That's right.
And then you move it to a place where you want the oxygen,
Yeah. So
phosphorus accumulating organisms to grow.
that's right. It actually goes to the head of the plant there. And at the very first reactors, they're not aerated. We call them anaerobic reactors.
Anaerobic.
No oxygen.
Oh, I think we're, I don't know if the film is looping a little bit. Yeah.
Okay.
And the reason for that is we want to promote the growth of certain bacteria. And with the anaerobic followed by the aerobic, you promote the growth of what's called biological phosphate accumulating organisms.
Like these organisms naturally accumulate phosphorus.
Exactly. Perfect.
Got it. Okay.
But you got to have the anaerobic followed by the aerobic for that to happen.
Because you need to get the ones that grow, the bacteria that grows
Under
in the
those
absence
exactly.
of oxygen first.
That's right.
And then you move it to a place where you want the oxygen,
Yeah. So
phosphorus accumulating organisms to grow.
that's right. So these organisms like it when when you turn the air off and then you turn the air on.
Mm-hmm.
They grow under those conditions. All of this.
All right, so I'm gonna pause here. By the way, shout out to y'all. Thanks, Dr. Tills, for letting me know I was muted earlier. When I was there with you, Dr. Reyes, and we have you here, Dr. De La Reyes, we have you here, Dr. Francis, here for a live explanation, rather, illustration of how that works, right? You just explained how there's a aerobic or anaerobic, and then there's an aerobic process. Can you break that down a little bit?
Right. So, I mean, we're actually trying to influence the microorganisms that are living in these reactors, right? Because really, we're using microorganisms to do the work for us. So they don't know that they're doing the work for us, but that's what we're doing.
They're just doing what they do. These microorganisms
they just want to grow.
Yeah.
That's right. They just want to grow and grow as fast as possible, eat as much stuff as possible. But what they don't know is they're eating our waste, right? So the organic matter, let's start with that. When the air is on, they eat the organic matter. Think of it as food. Mm-hmm. For us, that's the contaminant, but for them, that's the food. And so they grow. And that's taking care of the organic matter that actually we want to remove, because they, if you put that into a receiving body of water like a stream, mm-hmm. then it's going to eat up the oxygen in the stream. Now, for the phosphorus, I was explaining that we were turning the air on and off because we want the specific groups of microorganisms called PAOs, phosphate accumulating organisms. We want them to grow. So when we turn the air off, that's called anaerobic, and then we turn the air on. When we do that cycling, these microorganisms do something special. It's like I think my analogy was we're microorganisms in a cafeteria, you and me, Dr. Nee.
Yeah.
And then the lights are turned off. Well, guess who's gonna eat a lot of the food? The folks that can see in the dark.
The people that can see in the dark.
Right?
Eat in the
that's
cafeteria
right.
when the
So
lights
if
are
you
on.
and me had that's right. If you and me had a superpower and we can see in the dark, we'll grab all the pizza in the cafeteria, and then when the lights come back on, the rest of the folks in the cafeteria are wondering where the pizza went, but we already grabbed it. And then when the lights come back on, we start eating that pizza. So it's kind of like we're grabbing the food when the lights are off, and then we're eating the food when the lights turn on. So it's very similar. It's a little bit more complicated than that. I'm simplifying things. There's actually a huge biochemistry here that's happening. But it's similar. We turn the air off. The microorganisms do something. They take up what's called volatile fatty acids, and then they cycle through accumulating, this polyphosphate molecules when the air is turned back on. So that's what they're doing.
And that's what you all just saw Dr. Francis explaining to me. We had a nice little chat there where he gave the entire story. So basically there's a process that anaerobic aerobic process basically stimulates the organisms from grabbing the food, which our waste is their food, right? Our you know what I mean? But grabbing it and then actually eating it. Another thing you shared really quickly before I keep going is, how did they discover this? How was this discovered? by the way.
Oh yeah. So that particular story with the phosphorus removal was discovered in South Africa because it was a serendipitous, surprise finding, because they had frequent brownouts or blackouts where basically the power goes off. And so when the power is going off, let's say over the weekend, then they lose the capacity to blow air. So they lose the aeration.
Right.
And then when the power comes back on, they were measuring the phosphorus and they said, whoa, how come our phosphorus actually just went down dramatically? And so, the fact that they had a brownout, loss of power, they figured out that if you turn the air off and then turn the air back on, you get the phosphorus accumulating, phenomenon happening. So that was pretty cool.
Yeah, accidental discovery that end up working out for innovation, right?
It's the biological stuff, right? Mm-hmm. All of this is designed so that the microorganisms that are doing the organic matter removal, the nitrogen removal, the phosphorus removal are happy.
Got it.
Because they're the ones doing the job for us. We're just using the microorganisms to do the job for us.
Got you. They're doing the work.
They're doing the work.
What they naturally do.
Which exactly, yeah. But we're accelerating them in this system, yeah.
Got it.
So what happens here is all that liquid from we call that the activated sludge, biological nutrient removal system. It goes into here. It actually goes into that inner ring first, and then it's baffled so that it's, it doesn't stream out. It's nice and quiet. What you want is for everything to settle down. So at the bottom of this clarifier, it's got the slight incline. It's like a small cone. At the bottom, you actually have the solids coming down. And again, you can see that scraper going around very slowly.
Ah, that's moving.
It's moving.
Yeah.
It's doing two things. Anything that's floating on top is again being skimmed.
Yeah.
And then anything that settles to the bottom, there are kind of like squeegees at the bottom.
Yeah.
And they're scraping the bottom of the floor of this clarifier.
Stopping it from settling because...
No, they're
And just to hear, just for a quick check, and I'm gonna keep going, but here you take a sample. I know you're talking about this settling tank, but here on this sample you just kind of pulled up out of the water, we can see how at the bottom of it, because of how it works, it's dirtier than it is at the top of it. Right, Doc?
That's right. Yeah, it's amazing how clear that is at the top, right? So that's your secondary effluent already from this clarifier. So all that biosolids, they have all the microorganisms at the bottom. There's a pump that actually recycles that and pushes it back to the front of the plant. So basically the microorganisms are not lost. They stay in the system.
Right.
But then the water on top is now the effluent that goes to the next process.
Right. So now the water, so chat, y'all already see the water at the top is so much cleaner already, and we're not done. So let's keep it moving.
Bottom of the floor of this clarifier.
Stopping it from settling because...
No, they're collecting
It's collecting it, okay.
They're collecting it, and so it goes to the middle.
Make sure it runs down the
all
middle.
of that sludge
collects in the center.
That's right. So
because the conical...
you have clean water on top, right? And then all the biomass, all the brown stuff is actually in the middle, and it's actually pumped back into the front of the plant.
Okay.
Where you saw the anaerobic selector.
Got you.
So that there's a recycle, yeah.
It's recycled through.
Yep.
Got it.
So these are the sand filters. The
inside of there is sand, basically.
It's sand, that's right.
You're running water through sand.
Exactly. So all it is the water comes up on top, it floats through a sand media, and basically the other particles are trapped in the sand. What's unique about this is it's a self-cleaning filter. If you have a filter at home, let's say your Brita filter, after a while you got to throw them out, right?
Right.
Or your refrigerator tells you replace the filter.
Yes.
Because it's clogged.
Right.
Now, we can't do that here. We have to find a way to clean the filter. This is a self-cleaning filter because of the way it operates. And it's, in summary, we don't have time to go through it, but in summary, there's an air tube. Each of these safety cones is an air tube.
Yep.
And air is pushed down to the bottom, and that air goes up inside an inner tube, and as it goes up, the sand from the bottom rises with it. It's being cleaned, and then the sand is deposited on top of the bed. And then the dirt is separated out.
Right.
And so that's happening all the time. So the sand is actually going in, being cleaned.
Cleaned out.
So clean sand deposited on top, and then the dirty sand from the bottom, continuously.
Ah, okay.
So it's
and
a
so as
self-cleaning.
it continues to do that, more and more dirt is coming out.
That's right. And,
Oh,
and the
okay.
dirt is just continuously being cleaned, yeah. It's being removed, yeah.
Got you.
Yeah.
Got you.
Otherwise, in a drinking water treatment plant, typically you have to stop the operation, do something called backwash, where you actually put a jet of water up from the bottom,
Yeah.
clean the whole thing up, and then let it settle again.
Oh, so backwash is good.
Backwash in that case is good. Okay. Well, so before we discharge the water, one of the things that we want to make sure we actually do is we take out what's called the pathogens.
Yeah.
So we measure them with coliforms. So coliform bacteria and E. coli.
Yeah. Okay. Yeah.
So we are required to actually cut down on the bacteria level. We can do it a couple of ways in general. One is we can use chlorine to disinfect. Think about bleach, right? That's a lot of chemical, right? Bleach and chlorine is something that you don't want to handle, right?
Right.
And then when you chlorinate, you have to dechlorinate because you don't want all that excess bleach going into your river.
Right.
So most plants that are more modern, they use what's called ultraviolet disinfection.
Okay.
So this is UV disinfection, UV light. What UV light does is, if you're a bacterium and you get hit by UV light, even for a brief second, your DNA gets scrambled.
Really?
Yeah, so what happens is biochemically, you get all kinds of, AT pairs, thymines that are actually mutated. And that makes sure that you can't grow again or you can't multiply.
Right.
So you might live for the next 5-10 minutes and then that's it. You can't divide.
I can't get any more
That's right.
DNA.
That's right.
Okay.
So this is called UV disinfection.
Okay.
So we'll take a look. What's your step? So the placement of the bulbs and then the water flow is all modeled by computational fluid dynamics to make sure that no particle escapes. Every water molecule gets hit by the light.
Got it.
Yeah, so you can see the UV light.
This water is so
That water
clean.
is really clean. It looks really clean.
This is the cool part,
Wow.
yeah.
Is that so? You all chat. By the way, this is what Doc
it's
said.
coming out
If
of a
I felt
faucet.
comfortable enough, I could take a sip, right?
Remember,
Well, I can tell you that, there's other stuff that we're not required to remove that you probably don't want.
Okay, got it, got it.
but
I'm glad I
from,
didn't take a sip then. How about that?
Yeah, but from a pathogen standpoint and some of the other stuff, it's actually quite clean.
Quite clean. Okay.
Yeah.
So what we're about to do now? Tell her what we're about to walk to now, because we got a few more minutes of this, but we're about to walk where?
Right. So now we're looking at the biosolids part. So remember when the microorganisms were growing, we need to remove them also. So part of that is recycled, but part of that is also wasted because we have to control how much biomass we have inside the system. So we have to continuously waste also. And that biosolids also needs to be treated before it can be discharged. And so that can become fertilizer, for example, added to land, that's good for growing crops, but it's got to also meet certain requirements.
Got it.
In this particular plant, not all of the processing is happening in the plant. They actually have a sister plant where they take the biosolids and it's treated there through a process called drying. And in the end, they actually come out with pellets that can be used as fertilizer.
And I'm gonna see that.
So
I don't know if we got a shot of that, but right here where we're standing, let's see. I think this is where you said trucks come into like the plant and essentially take the poop
So you're treating
that
it
you all
just so
filtered out
you can be friendly to the environment.
That's right.
you can use it as
and
fertilizer.
take it to
for
another
example,
spot.
right?
Let's see.
Yeah.
It's got the nitrogen. Remember, it's got the phosphorus too.
Phosphorus and
We remove the
nitrogen.
phosphorus in the water. It's now in the solids. So in this particular plant, the complete treatment is over at the other plant. But to get from this plant to that plant, they actually pump it here.
Whoa.
And so we're standing under the Nickelodeon.
You mean the goo? This is where the goo, the brown goo, the goo that
So trucks come in here,
Yes.
right? And then they turn on the thing, and actually they have a vault on the top, and they fill up their 10,000 gallon truck, and then they drive to the other plant.
So it's the radioactive poop.
No.
Not radioactive. I'm just saying that 'cause that's what comic books say. But it's the poop that has a lot of
Solids. That's right, for further treatment.
For further treatment.
That's right.
Okay.
So it's just the arrangement in this plant that they do it that way.
They do it that way.
Some plants they do it everything in house.
Yeah.
So they don't need to transport it out like that.
But let me be honest with you. Let me just ask you a straight up question. Is the poop that they take out from here after it's gone through the process more valuable than the poop that I left in the toilet?
Oh yeah.
It's more valuable.
Oh yeah, it's got
yeah.
first of all it's cleaner from the point of view of pathogens and all of that, right?
Yeah.
And also you can reuse it as fertilizer.
Wow.
Yeah.
That's some valuable. Oh!
Oh! Smell.
Oh!
This is crazy.
So this is like the entire town having BBG. The bubble guts. This is like a town worth of bubble guts right here. That's disgusting.
So remember, these are the old microorganisms. We call it the biomass in the biosolids.
Okay.
What we're doing is we're letting them in there for a few days just to cannibalize, eat each other up. So that's a good thing.
Yeah.
And then it becomes a little bit thicker.
Okay.
And then that's ready to be pumped, using those trucks that I showed you earlier.
Yeah. Yeah.
Yeah?
Yeah. I don't know how I feel about this. Because can't we just... I don't know. Isn't it good as it is? Like, we need to optimize the poop. But it's for the environment, though.
It's for the environment.
For science.
Yep, for proper treatment.
Proper treatment.
This particular plant is unique. I told you that actually those blue hoses around,
Yeah.
it sprays, I don't know if you can smell it. It sprays a little bit of musk or...
a little Ralph Lauren, a little...
They actually spray a little bit when it's needed.
Okay, cool.
Not all the time, but when it's needed.
I was actually holding my breath the whole time, so now that you say something, I do smell that. It doesn't smell too stinky.
No.
Yeah.
It smells like it's not lavender. I think it's musk.
It's like legit musk, like the scent for colognes and stuff. Get out of here. This is crazy. This almost is making like almost every joke, no matter what you do to a turd, it's still a turd. Contraire,
That's right.
mon frère. If you can deodorize it and ship it off,
It's a deodorizing system.
Listen, you can make a little bit of money off of that.
That's right, yeah.
All right, cool.
That is crazy. I gotta pause here, Doc, because I saw herself's question in the chat, like, are the fumes dangerous? And I was thinking the exact same thing. As you all saw, I was kind of holding my breath the entire time I was seeing all that bubbling until you let me know that this actually didn't have the original smell. They were deodorizing it a little bit with the actual musk type scent. Talk about that really quick.
Sometimes it's musk, sometimes it's more cinnamon. But they're conscious about smells, right? Because there's actually development around the plant, and that's one of the things that wastewater, operators and plants take pride in that people don't know where they are. People don't know what happens, because the worst thing is for actually people to know where the plant is, because that means they're smelling them, right? And you don't want your town to actually smell. So that's very important, to make sure that it's almost like a secret that people don't know that you're there.
Right.
That means you're doing a good job, right? But so they were cautious about the smell of this particular plant. It's all good.
So and we talked about that. You showed us, and we don't have a clip of that, but there are companies that essentially make poop cologne, right? Wait, that's what I called it, but it's basically something to help the poop not stink as bad, to help the poop not smell as bad as your typical poop, and it's all for, again, the where the placement is not disturbing the community and environment as much with such a horrible stink, right?
That's right. Yeah.
And that, go ahead. I'm sorry.
No, go ahead.
Well, I was gonna think that highlights also, again, the difference between sort of, well-resourced, developed areas versus others that don't. And I think it's important to kind of re-interject that too, because we are at a place that sort of had resources, that had processes that may not be in every part of the world, right? Like, I don't think every, plant like this has the ability to make their poop smell good, right?
That's right. Yeah. And more than that, actually, in most of the world, what they have are on-site systems. So maybe pit latrines or septic tanks. So think about a hole in the ground.
Mm-hmm.
And then people, essentially, it's just under you, right? You may have a slab with a hole, and then it's underneath. And then when it's full, it has to be emptied.
Right.
And sometimes even emptied manually. We didn't talk about this, Dr. Nee, but sometimes people actually have to go down there to the pit latrines and empty it out, bucket by bucket.
Yeah.
And sometimes they do have trucks that come in and suck those out. So they don't have sewer lines, because I told you they were expensive.
Mm-hmm.
But they have these trucks as a service. They pump it out and then they take them hopefully to a treatment plant. But sometimes they don't even have a treatment plant, and so guess where it goes? Sometimes to open land.
Oh,
yeah,
wow.
Open land.
Just dump it, yeah.
Like there's no treatment, or sometimes straight to the river.
Man. And then hopefully in those cases it gets diluted enough. Yeah, that's a difference.
Yeah, there's a difference. But if you think about a lot of the rivers, especially in urban areas in low-income countries, they're usually quite polluted because of all of the things that the water gets. Yeah.
Right. Okay, we got about like 2-3 more minutes here on our vlog, but I'm gonna share this. Yeah, everyone's reacting in the chat. But now you're about to take us towards the outside of the plant, and I think I'm gonna play this a little here. This is reclaimed water that you're talking about here at the front.
They're held in this big 2 million gallon tank behind you, that dome right there. That's
the dome, yeah, we see that. You can see that driving by sometimes.
Right, and so they chlorinate that because you got to have a residual disinfectant. And then all of these purple pipes are universal for reclaimed water. So if you see in the building purple pipes, that means it's reclaimed water.
Yeah.
And in this town, you can actually just go in here and fill up your truck with water. With water, reclaimed water, and you can use that for your business, for irrigation, and so on.
I had to say water because we just saw finished looking at poop, so I was like, they fill it up with water in this case. This is the reclaimed water.
You gotta have
So this is the clean water, yeah. It goes to additional disinfection.
Where are we going, Dr.
Yeah, I'm sorry, I didn't mean to cut it, but yeah, that's something you all, well, they just have at the front of the facility that trucks can come and use, right, as needed.
And now we're going to see the outfall.
The output. All right, now we're going to see the output of the.
We're going to where the effluent from the plant is, so we call that the outfall.
The effluent plant?
Yeah.
Okay.
From the wastewater treatment facility. We're going to where it meets the stream, so you can see the difference between the effluent and the stream.
Okay.
So that's actually the.
That's the water coming out?
Yep. So that's the water coming out. That's the wastewater.
Wow. It's really clean though.
And then I want to show you.
Really clear.
Yeah.
Okay.
I want to show you how it meets the stream.
Okay.
So that's the wastewater.
Yeah.
You can see the
entrainment.
Air. And also you can see how clear it is, right?
Yeah, it's very clear.
That's the creek that it's meeting.
So this is the wastewater coming back in with the natural.
That's right. And you
water.
can see the difference you can actually see the
wow.
the difference, right?
So the water coming out of the wastewater coming out after it's been treated is far more cleaner than what is in the natural creek here.
Yes.
You can see it merging here.
Yep.
It's like the natural water that people feel like it's perfectly okay to drink and bathe and swim in.
Yep.
Right? It's like, you get away from me.
Yeah.
You natural, untreated water.
So that's why I want to show you this, because this is exactly how it meets the natural, creek.
That is awesome, and you can see a little. You can
see the
as it merges together.
As it merges together. That's right. Yeah.
Doc Francis, we really appreciate it.
Yeah.
Thank you so much for the time.
Yeah.
Thank you for meeting me at a moment of rebirth earlier at the plant.
Okay.
And I'm just super happy to have had this opportunity to see this whole process with you.
And I hope you now know exactly how your water gets treated and gets cleaned.
Yes, we do. Yes, we do. I have a whole new respect for the work that these folks do of making sure all the stuff comes out of my water.
Doc, that was awesome. Y'all show some love. I want you to clear up something real quick before you go. I'm gonna pause here. It went back to the beginning, but someone asked a question in the chat. Did we drink that water as recycled, sold in the water bottles in the stores? I don't know if you know anything about that process, but it's not exactly the same thing, right?
It's not. No, this is the treated wastewater.
Yeah.
And so what happens is there's an additional treatment process, kind of like another drinking water treatment plant that happens. So basically, this is the wastewater treatment plant, and then there is a drinking water treatment plant that takes water from different sources, maybe groundwater, maybe from a river, and then they actually go through a whole series of chemical and physical processes to make it clean. And that's your clean drinking water. So there's multiple barriers to protect public health. Yeah.
Got you. I saw some drinking water stabs and slanders in the chat earlier. So I'm glad you all know. Listen, there's a whole nother process after the wastewater has been treated that the drinking water then goes through. At least as we again want to point out, in developed areas and in real resource areas, for sure. Do you want to share anything for the road, Dr. Reyes? We showed a lot of stuff, but we didn't get to show any pellets. But it's good to know that there's a whole nother industry. Some of y'all got some insight for other STEM careers and engineering careers you can go into, all with under the umbrella of environmental engineering, like Dr. Francis is a part of. But any parting words really quick? This was fun. I just want to say thank you for letting me hang out with you there.
So actually, you know what? We call it wastewater, but actually think of it as it's a water resource, right?
Yeah.
And think about the fertilizer that we can get, and in some places, we can actually get energy out of those biosolids.
Ooh, yeah.
So it's really now not just waste treatment, but it's actually conversion to energy and resources. So it's more of a circular economy that we're trying to promote here, and that's the future.
Yeah.
The future is, your waste is actually valuable and it's actually a resource.
Absolutely. Well, y'all drop some love in the chat, give some emotes, some emojis. Let's thank Dr. Francis de los Reyes for pulling up and allowing me to pull up rather. And we just kind of have that nice little vlog tour here on the stream. That's right, Razzle Dazzle. Chemistry, microbiology, engineering, all of that is going on. Thank you for the education, Doc. Thank you for hanging out with us here on Building Stuff with Nova. I want you all to understand really quickly as I let everybody know that we do have another full week of programming next week. We're going to be at 1 p.m. every day next week, live on Twitch every single day, as we typically are. Some of our days we are going to get back on YouTube, but make sure you hit follow on Twitch. Make sure you subscribe so you all can continue to get this great content. And don't forget, we have pinned a couple of links on our Twitch chat. Obviously, this is our last day for applications to be considered for our virtual escape room, which will be the finale. But also, take some time to participate in our survey. You should see that pop up periodically in the chat whenever you hang out with us from this part moving forward. It's for us to get the insight and evaluation necessary for this research that we're doing in companion with Building Stuff with Nova. But with that being said, I just want to say thank you again for hanging out with us again today. Thank you again to Dr. Francis for sharing with us where our poop goes, where the wastewater goes in such detail and thoroughness. And with that being said, I hope you all have a great week. I hope you all are mindful about your water consumption. Every time you flush, watch what you flush down the toilet. And at the end of the day, in everything you're doing, continue to strive for your best, to get better and better with every iteration, just like that water does. And hey, keep building. Y'all take care. Peace.